Okay, so I'm going to start with 17A 1 through 4. It says find 3 consecutive integers such that the sum of the integers plus 4 is equal to 4 times the second integer. So the first one, it asks, how do we represent these integers? So when we have consecutive, they're in a row. So I'm going to represent the first one with n, and I'm going to label them because that might help us. Our second one is going to be one more than the first one. So n plus 1. And then our third one will be one more than that. So n plus 1 plus 1. I'm going to write that really tiny, n plus 1 plus 1, which is the same thing as n plus 2. I don't know how clear that is. Okay. So now when I read through the problem, the sum of the integers. So I'm going to add all 3 of these together first. So the first one plus the second one plus the third one. So I think some of the hard part on this is getting the words to equations. And I just always do it like left to right when I'm reading the sentence and then left to right writing the equation. So the sum of the integers, and then I'll pause and write that, plus 4. So this is my sum of the integers. Now I'm going to just plus 4 is equal to, so that gives me that equal sign, 4 times the second integer. So our second integer, we're going to go up here and look, that was the n plus 1. So I can fill in the second integer part with n plus 1. Okay, and then once you get to here, I wouldn't say it's super easy because it looks long, but it's really not too bad. There's just n's and some numbers. So we're going to have to combine all of these together. I'm going to color code mine. And then the numbers. And then we'll have to distribute and multiply over here. So I have 3 n's. And then I have a 1, 2, and 4. So that's plus 7. And over here, I did put that second integer in parentheses because it was not just one number. So the n plus 1 needs to go in parentheses because when I do the 4 times the n plus 1, I need to distribute the 4 to the n and the 1. So it'll be 4 times n and then plus 4 times 1. Now this looks hopefully more simple and easier to solve. I'm going to move the 3n over here. So I'm going to subtract 3n on both sides. I'll have n plus 4. And then I'm going to move the 4 over by subtracting it on both sides. And so Drew, what'd you get for n?
3.
That's right. Okay, so then what are integers? The first one is n, so that's 3. The second one is n plus 1, so 3 plus 1 is 4. And the third one is n plus 2, 3 plus 2 is 5. So make sure that you finish answering the question at the end that it's 3, 4, and 5.
The thing I did was I made every single different integer. Like it wasn't, I didn't do n plus 1. I just did like n and like, I didn't do another number, but I did like n1.
Okay. So yes, so you have to relate them all together or then you have too many variables in the equation to solve it. Let me see if there's a harder one. First, I gotta figure out what I assigned. C and H, okay. We'll do 4 through 6 on 17C. Okay. 3 consecutive integers. Oh, I should have done 1 through 3. Okay, changing my mind. We're gonna do 1 through 3. All right, find 3 consecutive even integers All right, so first I'm just going to stop there. My first one's going to be n. If I want the next even one, I'm just going to make up a number just to help me. Even integers would be like 10, 12, and 14. If n is 10, what is 12 going to be in reference to n?
N plus 2.
Right. So anytime we do even or odd integers, you just start doing +2, +4 instead of +1 and +2. So then this one would be 14 would be that. But I'm going to erase these numbers because that's not what the numbers are. That was just to help me figure out what n was. This is my first, this is my second, and this is my third. Okay. Now it says such that 5 times the third. So 5 times the third one. So I just go to the third one and I pull that whole thing, n plus 4. Minus 4 times the first. So I put a 4 and then the first one is just n is the same as 4 times the second. So my second one is n plus 2. So I put that in. And then as you start to work this, just make sure that you distribute that 5 to the n and the 4, and this 4 to the n and the 2. So we can both work that out. Oops. All right, let me know when you're done, Drew.
I'm done.
All right, what'd you get?
4.
Good. Okay, so if the first one is 4 and we're doing even integers, we put 4 in here. What's our next one?
6.
Yes. And then 8. So that's number 3 right there, the answer to part 3, solve for all the integers 4, 6, and 8. So don't forget to list all 3 of them. And then you can double check. It's a little bit easier. This is our first one, our second one, and our third one. We can go back and read that again. 5 times the third one, so 5 times 8, minus 4 times the first one, which would be 4, should be equal to 4 times the second one, which is 6. So 5 times 8 is 40 minus 16. Is that equal to 24? And if I can subtract correctly, I believe it is. Which is good, because I thought I solved it right the first time. All right. Do you think that helps enough? Do you want me to do any other ones?
That helped a lot. Yes.
Okay, did I assign? I did, both the honors ones. I didn't look at that. How'd you do with the, did you do 16H?
I did.
Did that go okay?
It did. I think I got everything right.
Okay. All right. 17H should be a bit like your projects, kind of, except that you don't get to choose everything. So I'll let everybody try that on their own. And then I heard that everybody took their projects home. Is that right?
Yes, ma'am.
Okay. Make sure that you bring that back because I haven't looked at them at all. Unless you don't want to grade.